we'll just increase that a little bit. No, that's right. Okay, so we've got our little sum there. I do need to increase that just a little bit. There we go. Remember what we said last time is when you're doing these for real, you need to make sure that you are writing your PN. Okay, so this is 2E. We talked about last lesson, or sorry, at the start of this lesson, that we don't have to do any of the inequalities and we don't have to do the recursive stuff, so check your outline. All right, we remember that this whole sum stuff, what that means, and by the way, you would write your PN, so I'm going to be a bit slack with this because we just want to move it along and get the algebra under control. So always make sure that you write your PN statement. When you are looking at this, we can see that this starts with the 1, so that would be 1 over 1 times 1 plus 2 is 3, and then it keeps on going. The last statement would be 1 over n, over the I as you replace it with the n plus 2, and that equals our right hand side. Capiche? All right, so we want to prove that P of 1 is true. So left hand side is going to be 1 over 1 times 3. Last time I checked, that's 1/3. Right hand side, 1 over 1, 1 plus 2 is 3. Oops. It is 3, but it shouldn't be a plus, it needs to be a times. That's what happens when you rush. We get 1/3. We say this is the left-hand side, and you must say that P1 is true. So in the scheme of things, the maths that we're doing so far is very, very small. And I'm now just going to write my PK and prove that PK1 is true. Just going to write that statement. All it is substitution. I'm not doing anything. So I'll pause the vid while I write that, and then you can be doing it and I will wait for you. So just substituted stuff in. Be warned, I've run out of room here, and sometimes this is where people will make an error. So 3k plus 1, so I've just gone 3k plus 3 plus 5 gives you the 8. So you want to just double check sometimes with the harder ones that we do later on. Do something to the side. Because if you make a mistake at this point, it sucks, right? Anywhere along here, if you make a whoopsie, you're going to go back and do stuff that just, it's annoying. All right, so here we go. I start with my left-hand side, and the reason that when I write this out, I make sure that I include my kth term, because then it's really easy to see that that whole thing there has to be replaced with PK, which is the whole point of induction. You are assuming that PK is true, helping you to prove that PK plus 1 is true. The domino effect. Okay, so therefore, we can now say my left-hand side, all of this is in fact PK, which is K, 3k plus 5, all over 4, k plus 1, k plus 2. Again, just copying. And we must include our k plus first term. So all over k plus 1, k plus 3. So up until this point, very little maths has gone on. It is at this point where we want to rock a little bit of maths. Whenever you see fractions, what do you want to do? I've got some people going the cross and they want to do the cross multiplying. Yes, except here, when we're adding the fraction together, we want to make sure it is in fact the denominator is the lowest common denominator that we can think of. So if I cross multiplied, I would get a little bit of a disgusting situation going on there. So what is my lowest common? Well, 4k plus 1, k plus 2, and I'll have to have a k plus 3, but that's already got the k plus 1, agreed? So my lowest common is going to be k plus 1, k plus 2, and hello there, k plus 3. Agreed? And then you're doing that thing. Wish my year 10s were here at the moment because they're doing little algebraic fractions, and when are we going to use this again? Hello. What did I have to times this denominator by to make it this? K plus 3, so it's going to be k 3k plus 5 times k plus 3. Everyone happy with that? And then in this denominator, we've got the k plus 1, we've got the k plus 3. So the extra thing that we're going to have to multiply through by is the 4k plus 1. So that's what we will do to this bit up here. So that's why that ends up being 1 times 4, k plus 2. And you go, yeah, okay. A little bit disgusting, because if we always look at what we're trying to get to, we're happy we've got the 4, we've got the k plus 2 and the k plus 3, but this k plus 1 is not in our right-hand side. So what is that basically telling you should be happening? Yeah, it should be that on the top line, we should get a common factor of k plus 1 so we can cancel it out. If we don't get that, something is going a little bit amok. Right? It's the same sort of thing when we do first principles. You know that certain things have to cancel, so you know that you're on track. Normally, at this point in time, I would look at the top line and I would go, oh, please, 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 is there a common factor? Alas, alack, I haven't got a common factor. So